Hopefully you guys can see and hear me. Week 2, we're going to do something a little bit different. I'm going to pull Zern up on my screen and screen share with you guys, and we're going to go over each lesson together. This week you are doing lessons 21, and then we're jumping into module 6 and doing lessons 1, 2, and 3. Friday will be a catch-up day. So if you have not sent me science, you need to reach out and ask me what you're missing if I have not already messaged you, and get that turned in by May 2nd. If I don't have it by then, you will be marked with a 0. So please make sure that you turn in your stuff. Okay? I'm going to share my screen. Let's see. Where'd it go? I think this is it. No, that's not it. Can I see this? Yeah. Okay. All right, this is lesson 21, Shape Reader. I'm going to log back in because it logged me out. All right, here we go. Lesson 21.
Welcome, Zerner. I'm seeing a quadrilateral with 2 pairs of equal sides. Pick the shapes that could match what I see.
Okay, so on this question, it's saying which of these shapes are quadrilaterals with 2 pairs of equal sides? So if you see a shape that has 1 pair of equal sides, which is what we call the parallel, remember? Okay, so if you see a shape with 1 set, it is not an option. It has to have 2 sets of parallel sides that are the same length. So the very first shape is a square. I can see that it has 1 set of equal sides, and then it has a second set. So I can move it over here where it says 2 pairs of equal sides. This shape right here, I can see that it has 1 set, but these sides right here are not the same. So it would go over here. This is not a quadrilateral. Remember, a quadrilateral is a shape with 4 sides, and a triangle only has 3. Our shape right here has 2 sets of equal sides, and our rectangle also has 2 sets of equal sides. Now, I understand that you have your long sides and then your short sides, but the short sides are 1 pair and the long sides make the second pair.
Let's go through this together. This isn't the shape I'm thinking of. It's not a quadrilateral because it doesn't have 4 sides. This isn't the shape I'm thinking of. It doesn't have 2 pairs of equal sides. All of these shapes match. Each is a quadrilateral and has 2 pairs of equal sides. We can see them here, here, and here. The crystal ball showed this shape. Let's focus on this for now. Which names describe this shape? Choose as many as you can.
Okay, so we obviously have a rectangle, and it says we are naming our names that describe the shape and names that do not describe the shape. So we know that this is a rectangle, okay? Quadrilateral means 4 sides, so 1, 2, 3, and 4. This is a quadrilateral. A trapezoid is a shape that has at least 1 set, there's the key word, 1 set of parallel sides. This has 1 set, 2 sets, so that works. A square can't be a square because in a square, all sides have to be the same length. So I can see that this long side up top and this short side on the side, they're not going to be the same length. This is obviously going to be a smaller number. A parallelogram has to have 2 sets of parallel sides, so 1 set, 2 sets. And a rhombus Has to have all sides the same length. So it cannot be a rhombus because this side is not the same as this side. So let's check and move on.
This shape is a quadrilateral because it has 4 straight sides. It's also a trapezoid because it has at least 1 pair of parallel sides. This shape has 2 pairs of parallel sides, so it's a parallelogram. And finally, this shape is a rectangle because it has 4 right angles. It is not a square or rhombus because it does not have 4 equal sides. What is the most specific name for this shape?
Okay, and when it asks for the most specific name, sure, this is a quadrilateral, but there are a lot of shapes that could be considered a quadrilateral because they have 4 sides. Sure, it could be a trapezoid because it has at least one set of parallel sides. Sure, it could be a parallelogram because it has 2 sets of parallel sides, but the most specific would be a rectangle because you see that it's a quadrilateral. Okay, we know a rectangle has to be a quadrilateral. We know that it has to have at least 2 sets of parallel sides. So the most specific name would be rectangle. Pretty common.
Rectangle is the most specific name for this shape because it tells me the most about its attributes. Rectangles have 4 sides, 2 pairs of parallel sides, and 4 right angles. Aha! I'm seeing another shape, a parallelogram with no right angles. Let's draw this in your notes. Today, we're doing Mission 5, Lesson 21. We'll draw a parallelogram with no right angles. But before we draw, let's think. What attributes do we need to include when we draw a parallelogram?
Okay, so when you're thinking about attributes, you're thinking about characteristics. So what are the characteristics of a parallelogram? So the very first one says 4 straight sides and exactly 1 pair of parallel sides. Well, I know that this one would not be correct, so I could mark through it because a parallelogram has 2 sets of parallel sides. The second option says 4 straight sides and 2 pair of parallel sides. And then the last option says 5 straight sides and 1 pair of parallel sides. Well, we know that a parallelogram is a quadrilateral, so it can't have 5 sides, which means that the attributes of a parallelogram are 4 straight sides and 2 pairs of parallel sides.
A parallelogram must have 4 sides and 2 pairs of parallel sides. We also know that opposite sides are equal in length. I'll start by drawing 2 parallel lines of the same length, like this. Each is 2 units long. To make sure this parallelogram doesn't have right angles, I drew the lines at different levels on the grid. Your turn. Draw a pair of parallel sides. Make sure they are the same length and at different levels on the grid.
Okay, I know you guys don't have your Zern books, but what I want you to do is on a sheet of paper, do your best to draw this out because it's asking you not to have right angles in your shape. You do have to draw the lines at different parts on your little graph that they've got here. Instead of drawing it, side by side and making it look exactly parallel like the railroad tracks, it's going to be a little bit lower because when you finish drawing your lines here and here, that's going to give you acute or obtuse angles instead of right angles.
Now, draw 2 line segments that connect the parallel sides.
I'm going to fast forward so you guys can see how this turns out. Okay, so here's our shape. You see where they connected it because a parallelogram has to be a quadrilateral with 4 sides.
Let's use this word bank to write all the names we can for this shape. We know this shape is a quadrilateral because it has 4 straight sides. Can you think of 2 more names that describe this shape? Use this word bank to help.
Okay, so if we go through our word bank, we see square. Well, we know that a square has to have 4 equal sides and it has to have right angles. This shape obviously doesn't have 4 equal sides. You've got 2 small sides and 2 big sides, and it doesn't have right angles, so it can't be a square. We know that a rhombus is a shape that has all sides that are the same length. Well, again, we have a long side and a short side. A rectangle has to have 90-degree angles, okay? So we don't see 90-degree angles here. A trapezoid has to have one set of parallel sides. Well, it's got at least one set, so we could put trapezoid. And then parallelogram has two sets of parallel sides, one set and two sets. So on the lines, you would put trapezoid and parallelogram.
This shape is a trapezoid because it has at least one pair of parallel sides. It's also a parallelogram because it has two pairs of parallel sides. It's not a rectangle because it does not have four right angles. It's not a rhombus because it does not have four equal sides. It's not a square because it doesn't have four right angles and four equal sides. Check your work.
Okay, we don't need to check. We've already been over this.
Now,
Gonna move through. Okay, now, if you were looking for the name that's most specific for the shape, it's going to be parallelogram. Again, I told you that quadrilateral, there are a lot of shapes that could be considered a quadrilateral. You know, the square can be considered quadrilateral. It has four sides. The rhombus can be considered a quadrilateral. The rectangle can be considered a quadrilateral. But in this case, parallelogram is going to be the name that describes this shape the best. Okay, so it says, which shape is a rhombus that is not a rectangle? Well, we know that the definition of a rhombus is a shape that has four equal sides. So if I look at this shape, I see that there are different dimensions. They're not all the same. This shape has different dimensions. This shape has the same dimensions. And then I have this shape right here that's going to have the same dimensions as well. But it says the shape cannot be a rectangle, which means it cannot have 90-degree angles. So that eliminates this shape, and that means this shape would be our answer. This is the rhombus. Okay, it says names that describe this shape. Well, we know this shape is a quadrilateral because it has four sides. We know it's a rhombus because it has four sides and they're all the same length. It can't be a rectangle because it doesn't have 90-degree angles. You can see the obtuse angle here and here and the acute angles here and here. Okay, parallelogram, it has two sets of parallel sides. Square can't be a square because it doesn't have 90-degree angles. And trapezoid because it has at least one set of parallel sides. Okay, the most specific name for this shape is a rhombus.
your shape skills are impressive, Zerner.
Why, thank you.
Keep it up in the Tower of Power.
Okay, at this time, we're just going to move on to the next lesson. I'm not going to do the Tower of Power with you guys. The questions are different for everybody. So I'm going to move into Module 6, Lesson 1, and we're going to be talking about the coordinate plane. Now, if you do remember when I was teaching you LEAP prep, and we would talk about X and Y on a coordinate plane and how the X comes first and then we plot the Y point. That's what we're moving into. We won't do that right away. They're going to do a little bit of a review with you where you can construct a coordinate system on a line and naming points using coordinate pairs and use the coordinate pairs to plot points. And then the further we get into this module, you guys will be plotting those points. We will do lesson 1, 2, and 3 this week. 7, 8, and 9 will be next week, as well as 20 and 21. And then you guys are done with math for the year. We'll spend the last couple of weeks together just reviewing topics that I think that you might need a little bit of extra help on or that you might have forgotten. So we're going to jump into Module 6, Lesson 1.
Hey, Zernstar. Today we're going to work with number lines. Let's draw one. I'll get us started by drawing a line like this. I'll draw an arrow on each end to show that the line goes on forever in both directions.
Okay, that just means a continuous line.
Now we need to put tick marks on our number line. there should be an equal distance between each tick mark. Which number line shows how to draw the tick marks correctly?
Okay. If you don't have a ruler at home, that's perfectly okay. But you know that when drawing a number line, I really want to say this started in 3rd grade, and you might have touched on this in 4th grade, but I know for sure it's a 3rd grade standard that is taught. When you're drawing a number line, you want to make sure that all of your points on the number line are evenly spaced out. So if you put a finger down after you draw your first tick mark and then draw your next one on the other side of your finger and keep doing that, they will be evenly spaced. So if you don't have a ruler, that's a cool trick that you can use. We know that this number line is how we should draw tick marks because the lines are not evenly spaced here.
We need to make sure that the distance between each tick mark is the same. Let's place all of our tick marks 1 inch apart. I'll draw that now. I'll use this 1-inch square to help us measure.
Remember, if you don't have this, which most of you probably will not because it's the manipulative we would have had in class, then you just use your finger. And it's okay if it's not exactly 1 inch. Just do your best.
Our number line now shows equal units. Now we need to label these tick marks. We can make the labels on our tick marks increase in either direction. Let's go this way. I'll label this first tick mark 0. The point on the number line labeled 0 is called the origin.
Always.
You try. Label the origin on the number line.
If you remember in the coordinate plane, I told you the point that was at the very center of the coordinate plane was 0, 0. So that means that you always want to start with 0. And then it just continues. 1, 2, 3, and 4.
Now we have a labeled number line. Let's put a point on our number line. What if we wanted to describe the location of the shape without pointing to it? We can use its coordinate. A point's coordinate is its distance from 0. We use the origin as a reference point to tell us the location of the point. This point's coordinate is 2 because it is 2 units from 0. Now you try with this circle. What is the coordinate of this circle?
Okay, so if we start at 0 and we jump to every tick mark, we get 1, 2, and 3. And you can see that the dot is on the 3.
The coordinate of this point is 3 because it is 3 units away from the origin. 1, 2, 3. It's 3 units from 0. We can move this line in any direction and the coordinate of the point stays the same. What if I turn the line around so that the numbers increase in the opposite direction? Even though the line moved, the circle is still 3 units away from 0, the origin. What is the point's coordinate now?
Okay, so even though it's backwards, you still start at the origin and you go 1, 2, 3. Okay, and even if it's tilted, doesn't matter if it's upside down, sideways, crisscross, applesauce, regardless, you're always going to start at 0 and jump up. So 1, 2, and 3. Okay, if they do it this way where it's up and down, you're still going to start at 0. 1, 2, 3.
Our line can move, but the coordinate stays the same because the point is staying the same distance from the origin. Let's dive in and find more coordinates. Check out this number line. I'll put 4 shapes on the number line. What is the coordinate of the star?
Okay, same thing. We're going to start at 0 and we're going to jump up to the star, which is on the 1. So we moved up 1 space. Okay, the circle, we can see the circle here. So we're going to start at 0 and we're going to go 1, 2, 3. Okay, the triangle is here. We're going to start at 0 and go 1, 2, 3, 4. And then we're going to do our square. We're going to start at 0, and we're going to go 1, 2, 3, 4, 5, 6. Okay, we're going to do it again. So we're looking for the triangle. I'm going to start at 0. 1, 2, 3, 4, 5, 6, 7. The square. 1, 2. The circle. 1, 2, 3, 4, 5. And then the star. 1, 2, and 3.
Let's mix things up a little. In this next one, we'll partition each hole on the number line into a fractional unit. Let's use thirds for this first one. Label the fractional units on our number line.
Okay, so into what fractional part did we partition each hole? You would count, you don't use 0, you use whatever comes next. So this would be 1/3, 2/3, and 3/3, because 3/3 is going to give you one whole. So then when we write what our fraction would be, you don't use 0, okay? This would be 1/3. Then we have 2/3. 1 would be 3/3. Then we would have 4/3, because that would be 1 1/3. 5/3 would be 1 2/3. Then 1 3/3 would be 2, which would be 6/3. And then we have 7/3 for 2 1/3. Sorry, it gets a little confusing. Now let's find coordinates. Each shape was placed at a point on the number line. What is the coordinate of each shape? So we look at our square right here. I don't know if they want me to put it in whole number form. I guess so. So it would be 1 whole. Okay. The triangle is at 5/3. Again, I could put this as a mixed number, but I'm not really sure how they want me to put it. Our circle is at 1/3. And our star is at 7/3.
Let's wrap up now. We'll look at a couple more number lines with some tricky point plotting questions. Let's start with this one. Some of the tick marks are labeled, but some are not. Think about what fractional unit each hole is partitioned into. What is the coordinate of this circle?
Okay, so the very first thing you want to do is you want to look at your number line. And you can see that it's flipped backwards here. And that's fine. We're just going to start at 0. It's just going to be on the opposite side. And we can see that if we don't use 0, we have 1, 2, and then 3. So this means that this number line, sorry guys, this number line is split into thirds. So if I look, I have 1/3, 2/3, 3/3, 4/3. Okay, now let's plot a point. Plot a square so that its distance from the origin is 2/3. So remember, we don't use 0 because that would be 0/3, so it doesn't really matter. So we have 1/3, 2/3. Now they want to challenge us. So look closely at the number line, plot the circle so that its distance from the origin is 1. So we see that our shape is divided into sixths. So that would mean 1 3/6, 1 2/6, 1 1/6, 1 whole. Okay, and you can also tell that the lines for the holes are a little bit chunkier. So you can see that 0 is a hole. So you can see the chunky line, it moves up 6, and then that's a chunkier line, so that would be your 1. Okay, let's plot another point, plot the square, 4, 6, closer to the origin than the circle. Okay, so we know that this would be 0, so 1/6, 2/6, 3/6, 4/6. Oh no. Let's see what I did wrong. Let's plot another point. Plot the square 4/6 closer to the origin than the circle. It wants us to move from the square. So the circle. So be careful on this. Even I make mistakes, you guys can see, okay? So it says plot the square 4/6 closer to the origin than the circle. So that means we're moving from the circle and we're moving over 4/6. They don't want us to start at the origin. Okay, what is the coordinate of the square? So we're at 0, that would be 1/6, that would be 2/6. All right, let's plot one last point. Plot a triangle at the midpoint of the circle and the square. So this would be 1, 2, 3, 4. So 1, 2, it would go right in the middle. Midpoint always means middle. All right, and that's lesson 1. So make sure you're careful, especially on the one that I missed. If it asks you that similar question, which it should on the Tower of Power, make sure you start from the point that you previously graphed. Unless it specifies to start from the origin, you don't have to necessarily start from the origin. Okay? Lesson 2, it's going to be the same thing. We have the same standard, so we're constructing a coordinate system on a plane. Let's get started. We have one more after this.
Hey there, Zernstar. Today we'll continue to work with coordinates. Let's get it started in our notes. You'll need a ruler or straight edge. Today we're working on Mission 6, Lesson 2. This is line X. Let's complete this number line. I'll label the origin 0 at the first hash mark here. I'll label this 1. Your turn. Label the rest of the whole numbers on line X.
Okay, and I know you guys don't have your notes again, so that's perfectly okay. We can obviously see the difference between the tick marks. We have a thicker tick mark here, and then it's kind of smaller here. So that means that the thicker ones are going to be our whole. So we have 0, 1, 2, 3, 4, and 5.
I'll label the rest of the whole numbers like this.
Okay, exactly what we did.
What is the coordinate for this point and this point?
Okay, what is the coordinate of the green point? Well, we can see that the green, if we started at 0, it went up 1, 2. So 2 would be our coordinate there. And then for 3, you can see that you're going to have a fraction because it's halfway between 3 and 4. So that means we have 3 and 1/2.
The coordinate for this point is 2 because it is 2 units away from 0. The coordinate for this point is 3 1/2 because it is 3 1/2 units away from 0. Now, plot a point at 1 1/2 and label it A.
Okay, so they want us to do 1 1/2. If we were plotting this point, which I know you don't have your Zern books to do this, but we would start at 0, we would go 1 and then 1/2. So your point should be right here between the 1 and the 2.
I'll plot point A here. 1 1/2 units from 0 on line X. Check your work. We know how to describe the location of points, like point A, that fall directly on a number line. But how can we describe the location of a point that is not directly on line X, like here? Let's use our ruler to draw a second number line perpendicular to line X, like this. Your turn.
Okay, if you recall Elite Prep, we saw this quite often. And you even saw this in your iReady test that you take at the beginning, middle, and end of the year. We talked about how there were 2 coordinates or 2 lines. We have our X and then we have our Y. I told you that the X always comes first and then the Y always goes second. So that's what they're about to show you here.
Now we'll draw hash marks like this.
Okay, so you can see they did the same thing as the bottom. Okay, they did it in halves. If we have halves down here, like half, 1 whole. 1.5, 2 holes, 2.5, 3 holes. Then they're going to do the same thing over here. If you're working with halves, you're going to have to work with halves over here. Okay. Did the same thing we did. So they had a bigger line where you had a hole and a smaller line where you have a half. So we have 1 hole, 2 holes, 3 holes, 4 holes, and 5 holes.
We have 2 perpendicular number lines that intersect at the origin. Now we can describe the
And here's
location
your origin.
of any point
It's
in
0
this
and
area
0.
called
So
the
right
coordinate
here.
plane. We call the horizontal number line the x-axis, so I'll write that here. We call the vertical number line the y-axis, so I'll write that here. Your turn. Label the x-axis.
Okay, we're going to speed through him talking. So the x-axis goes here, and this is our y-axis. Okay, so it says plot point B. Make sure it's at the same place as Mr. Sawiki's, or however you say his name. Okay, so remember in class when I taught you this, I said you start at the X. So we would bring our mouse over to where it is on the X, and we would see that it is at 1 hole. Then we would move up to find the Y coordinate. So 1, 2. So this dot B is at 1, 2.
We can use both number lines to describe the location of point B. I'll show dotted perpendicular lines from point B to both the x and y axes. Let's use the distance from the x and y axes to describe point B. This point intersects the x-axis at a distance of 1 from the origin, so we can say that this point has an x-coordinate of 1. This point intersects the y-axis at a distance of 2 from the origin, so we can say that this point has a y-coordinate of 2. Your turn. Write the x and y coordinate for point B.
Okay, we've already solved this. So just again, to reiterate what he just said, if we started our origin, which is 0, 0, right here, we moved over to the 1, okay? The B is lined up with the 1 on the x-axis. Now, some of you might get confused, and you might start here, and you might say, oh, it's 2, and then, oh, it lines up with the 1. You cannot write it that way because you always have to start with the x-axis first. You're starting here. Then you can look and see what it's going to be on the y-axis. You've got to remember x before y, okay? So we have 1 hole, and then we move up 2 on the y-axis. So we get 1 on the x-coordinate and 2 on the y-coordinate. Okay, I'm going to fast forward him just a little bit because I think you guys get the memo. When you are graphing points on a number line, I know you're not doing this on paper, you're doing it on a computer. You will always label your point. Okay, so just like we would in a model when we give it a title and we label all of our names in a model, however we do it, you're going to have to label your point. So that's why they have their parentheses and their 1, 2. 1 is the x, 2 is the y, and they separate it with a comma. Okay, plot C at 3, 4. Okay, that's all that means is I'm going to start at 0, and I'm going to go over on the x-axis to 3, and then I'm going to move up 4 because my y-axis is telling me I'm going to go to 4. So if we were doing this in class or you were doing this on paper, your point would go right here at 3 on the x, 4 on the y.
Let's start at the origin. We'll travel 3 units to the right along the x-axis and 4 units up parallel to the y-axis. So point C is here.
Okay, and that's what we just went over. So I just wanted you to see where it was going to go. So you see how they labeled it, point C, and then they put their parentheses 3, 4. Okay, which picture shows how to label the x-axis and the y-axis? Remember, I told you the x always comes first, and it's going to be that bottom line. The y-axis is always going to go up and down. So this would be the correct way to label a coordinate grid. Okay, Finish labeling the x-axis and y-axis using whole numbers. So they're telling me I'm going to use whole numbers here. No fractions, just whole numbers. And it goes all the way to 10. Well, most of the time, if this one's going to 10, this one's going to match. So it's going to be 10 as well. I'm typing kind of fast, so if I mess up, I'm sorry. Okay. Then it says the cave is marked with a circle. How can we describe the location of the circle? So I would say 1, 2, 3, 4 units over and 1, 2, 3 units up. Over, then up. Always, always, always. The cave is marked with a circle. What is the x-coordinate of the circle? Well, here's my x-axis. I'm going 1, 2, 3, 4. So my x-coordinate is 4. And then they're going to ask me for my y-coordinate, and I'm going to go back to where I was, and I'm going to go up. I'm going to go 1, 2, 3. So my y-coordinate is 3. Okay. Look at our square. Now, these are tricky because I get that there's no mark on the x-axis, but technically it's on the origin, which is 0. So that means our x-coordinate has to be 0. If it's on the line, it's going to be 0, okay? But the y-coordinate still means we have to go up. So 1, 2, 3, 4, 5, 6, and 7. So the plot for this would be 0, 7. Okay, I'm going to fast forward him. A volcano is marked with a triangle. Plot the triangle at 5, 1. Well, I know x always comes first. So I'm going to start on my x-axis, and I'm going to go over 5. 1, 2, 3, 4, 5. And my y-axis is a 1, so I'm going to move up 1, and I'm going to drop off my triangle. The treasure is marked with a star. Plot the star at 1, 5. X comes first, so I'm going to start at 1 on the x-axis, and I'm going to go up 5. 1, 2, 3, 4, 5, because my y-coordinate is 5. Okay. Match each shape with its coordinates. So you can see here that we're obviously going to be using halves. Okay. You can see it over here. You see a half here and a half here. So be careful when you're plotting these points. So the shape for 3.5 and 2, so I'm going to go over to 3.5 and up 2 is a star. Okay. My next plot would be at 0, 4. So I know that 0 would be my x, and then I would go up 4. 1, 2, 3, 4. That's going to be the triangle. I have 5, 2. So I'm going to go over 5 and up 2. 1, 2. That's going to be our circle. And then that leaves our square at 2, 3.5. Which shape has a x-coordinate of 0? So we're looking for the one that falls on this darker line because it's going to start at the origin. If we follow this line across, we don't see anything on this dark line right here. So if we go up, it's going to be 4. So the coordinate of this triangle would be 0, 4 because the 4 is on the y-axis and we started at 0 on the x. What shape is 3.5 units from the y-axis? That's a good question. So this is the only one I see that falls at 3.5. So we're going to try the star. Had to look at it for a second. Okay, it says plot a heart at 2.5, 1. So I need to go to 2.5 on the x-axis, 1, 2.5, and then I need to go up to 1 on the y-axis and drop it off. Plot a hexagon at 1, 2.5. So it's flipped. So I would go over to the 1 on the x-axis, and then my 2.5 is going to tell me to go up 2.5 on the y-axis. And that's the lesson.
Excellent job working with coordinates, Zerner. Keep it up in the Tower of Power.
Okay, so do your best in the Tower of Power. And then I'm going to go back to the home screen because we've only got one more lesson to do, and then you'll be done for the week. So lesson 3 is naming points using coordinate pairs and then using the coordinate pairs to plot the points. Here we go.
Hey there, Zernstar. Let's keep working with coordinates. We'll start in our notes. You'll need a ruler
And I
or
know we
straight
don't have
edge for
notes,
today's
so if
lesson.
you have paper, that's fine. If you want to look at it and just visualize it, that's
Today
fine
we're
too.
working
Whatever
on
works
Mission
best
6,
for you.
Lesson 3.
Some people like to take notes.
Let's construct a coordinate plane from this grid. First, we'll draw the x-axis.
Okay, I'm going to speed them up a little bit. So you're using a ruler to draw a horizontal line that goes through point A, label it x-axis. So that means right here at the very bottom of our grid, if you can see the mouse, right there at the bottom of the grid, this is where you're going to draw your thicker line. This is going to be your x-axis.
I'll draw a horizontal line that goes through point A like this
So there's the thicker line.
and label it here.
Okay. Use a ruler to draw the y-axis. So then we would start on the far side line and we would go all the way up. Now they give you a little hint here because they say it goes through point B. So when you draw that thicker line, it's going to go through point B, and that's going to be your y-axis.
I'll draw the y-axis like,
Okay, and speed them up again. You're going to put 0 right here at this where they touch. So where they intersect, remember when we were learning shapes, I said you don't want any intersecting lines. On this coordinate plane, you're going to see an intersecting line right here, and this is going to be your 0, 0. This is going to be your origin. All right, it says draw hash marks and label the rest of the whole numbers on the x-axis. Keep in mind the length of each square is 1/4 unit. So that means that if we were labeling this out, we have 1/4, 2/4, 3/4. 1 whole would be 4/4. Then you have 1 1/4, 1 2/4, 1 3/4, 1 4/4, and it keeps going so on and so forth.
I'll label.
Okay. So let's see, they're just telling us to check. So they just labeled their wholes because we're working in fourths. You have 1/4, 2/4, 3/4, and a whole. Just to reiterate.
Now, draw hash.
Okay. They want you to do the same thing on the y-axis. Whatever you do to the x-axis, you're also going to do to the y-axis. It's kind of like a mirror. If you go all the way up to 5 here, you're going to go up to 5 here as well. Okay, see how they did that. Since we're using fourths, you have to jump 1/4, 2/4, 3/4, 4/4 would be a whole. All right, write the coordinate pair for point A. So we always start with the x-axis. And if I look at my x-axis, I'm going 1/4, 2/4, 3/4, 4/4. So that means I have 1 whole. And then if I go to move up, I really can't, okay? Because if I move up, that means I'm at 1 1/4. Because I can't move up, that means my y coordinate is going to be 0. So the point would be 1, 0. Okay, and we see where they did that. Then it says B. Well, I know that if I'm on my x-axis and it's on the line, it's going to start with 0, and I'm going to have to go up, looks like 4 1/4. So 0, 4 1/4.
Point B
I
has
hope I'm
an
right
x
because I can't
coordinate
really
of
see
0.
that well.
It
0.
intersects the y-axis at 4 1/4 units from
right.
the origin. So it
Okay, so we've got that. It says write the coordinate pairs for points C and D. I'm going to look at my x-axis and I'm going to move over until I get to C, and then I'm going to stop. I can see that C on the x-axis is at 1 1/4. When I move up to check for my y coordinate, I see that it's at 3 2/4. D, I start on the x-axis and I go over, is at 3 wholes. If I move up to solve for my y-axis, I'm going to be at 2 3/4.
Let's
Okay. And the reason you see 3.5 here, and that's perfectly fine, all they did was they simplified their fraction. So we would have seen 3 2/4, I want to say, and 2/4 just simplifies to 1/2. We know it's an equivalent. So it's okay if you do that. If you want to leave it in fourths, that's perfectly fine as well, unless it asks you to simplify.
now plot.
Okay. Then it wants us to plot E. Well, I can see that if I have a 4 in the x-axis, I have 2 3/4 in the y-axis. Since I always start with x, I'm going to go over to 4, and then I'm going to go up to, I hope this is right, I can't really see that well, and 3/4. So 1/4, 2/4, 3/4, and it's going to be about right in here.
We'll
We're going to fast forward so we can see. We were right, okay? Here's our E, which was 4 and 2 3/4. All right, label the first hash marks on the x-axis so that the point A is at 1, 1. So that means we would have to have, this is a whole. So that means I have 1, 2, 3. That means I'm putting it in thirds. So 1/3. I'm going to move forward and skip through him, okay? Label the first hash marks on the y-axis so the point A is at 1, 1. So if you label this 1/3, this y-axis is also going to start at 1/3.
The y-coordinate is
Okay. Which coordinate plane labeled the hash marks correctly? So you want to check really carefully and see which labeled them correctly. I know if I start with 1/3, the next thing on my number line would have to be 2/3. So that would make this one correct. Whoops. The reason this one is incorrect is because you don't go from 1/3 to 1/2. Okay, you go from 1/3 to 2/3 to 3/3. So that makes this one wrong. Okay, plot point B on the coordinate plane. Well, we see B is at 1 1/3 on the x-axis and 0 on the y. So I'm going to go over to 1 1/3, and I'm not going to go up because I'm at 0 on the y-axis. I have 1/3 and 1 2/3, so I'm going to go over to 1/3, and then my y-axis is going to be 1 2/3. And I plotted
point
both of
B
my
is
points,
1
B and
1/3
C.
units over on the x-axis and 0 units up. We can also say that its distance from the y-axis is 1 1/3, and its distance from the x-axis is 0. Point C is 1/3 of a unit over on the x-axis and 1 2/3 units up. We can also say that its distance from the
And you see how they're
y-axis
labeling their
is
points
1/3, and its distance from
with
the
A, B, and
x-axis
C.
is 1 2/3. Whoa, look at these points. What are the coordinate pairs for these points?
All right. So the very first thing I want to do is I want to look at my coordinate plane. I want to look at my x and my y axis to figure out what these little marks are that they didn't mark. Okay, I can see that they did my holes for me, but they didn't do every mark between a hole. So it looks like we're going to be in halves because this would be halfway between 0 and 1. This is halfway between 1 and 2. So I know I'm working with halves. It wants us to plot R first. So if I go over on my x-axis, because it's first, I know R is at 1. And if I go up, it's at 3. So R would be 1, 3. Okay, looking at E, we're going to start at 0. And we're going to go across on our x-axis till we get to E. So 1, 2, 3. So I know it's at 3 on the x-axis. And then I'm going to go up to solve for y. And I can see that it's between 4 and 5. So that's going to be 4 and 1/2. Okay, A, I'm going to start at 0. I'm going to go over. It's at 4.5 because it's between 4 and 5. And then I'm going to look at my y-axis when I go up, and it's at 1/2.
Excellent work today, Zernstar. Keep it up in the Tower of Power. Cool.
All right, so this is when you need to go and you need to do the Tower of Power. If you have any questions because you're unsure of anything, please feel free to take a picture and text it to me, message me on Remind, whatever you've got to do so that you can get these lessons done. If you have trouble with it moving you to Module 6 after you finish Module 5, Lesson 21, shoot me a message and I'll move you up. These lessons can tend to be difficult if you confuse your X and Y axis, and it's perfectly okay if you do. It's a common error. It just takes a lot of practice, and we're going to be practicing the next couple of weeks with the coordinate plane. Make sure you get these done and submitted by May the 2nd at 12 o'clock. If you are not completing your work, you are receiving an incomplete in the grade book. An incomplete, in my opinion, because we're not allowed to give you a letter grade exactly, would be like a 50%, which is an F, okay? You want to make sure you're completing your work completely by the due date. Now, if you have extenuating circumstances and you need extra time, reach out and let us know so that we can extend it for you and help you in any way that we can. You have until May 2nd at 12 o'clock. If you have any questions, you know how to reach me. Good luck. I miss you guys and love you guys, and I hope you enjoy coordinate planes as much as I do. Bye.